Introduction to myself. My name is Michael Vallette. I'm with DQE Communications. We are the premier fiber provider in Western Pennsylvania. One of the things that's always struck me about this company when I started here 2.5 years ago was how easy we are to work with. For example, we had a customer that was so hyper about reliability. They wanted connectivity to 2 of their data centers, and they wanted us to build fiber for them and make sure that those 2 fiber paths did not cross at any point. And we did that. Very often we will do things like make custom term agreements to match the leases left for our customers while they're in certain buildings. You know, if you've got 41 months left on a lease, well, what works better, a 3-year or a 5-year? No, we will write you a 41-month agreement for our services. It is my pleasure to introduce Doug Ramsey, Vice President of Business Development at Citrine Infomatics, and he is going to talk about their Citrination product, which helps organize diverse data sources using AI and intelligent machine data gathering to help make decisions. Ladies and gentlemen, Doug Ramsey.
Great, thank you. Okay. Can anybody hear me? Okay, great. I'm going to talk to you a little bit about what we do. We're a little bit different than a lot of the big data companies that you've heard from today because we have built a platform and a set of software tools that's very specific for the materials R&D community. And within the materials R&D community, we have a paradox. There is a lot of data. It's captured in proprietary databases. It's extremely competition sensitive. And in many instances, these are the crown jewels for the companies that are looking to develop new products, looking to develop new processes, and sustain competitive advantage. So there's big buckets of data that's out there. If you go out into the public domain and you want to Google or you want to go through any other public repositories to find this information, you will very quickly run out of meaningful data. Wikipedia will not solve your materials discovery process. So it's really about the business case, and it's about how we structure the business case. And I'm sorry Jim left because I loved a couple things that he said there. And at the end, he talked about the digital twin. 20 years ago, I was part of a working group in the Pentagon. And we were pursuing something called simulation-based acquisition at the time. This was a $2 billion acquisition reform program at the Pentagon. And we all got into a room down in Crystal City, Lockheed, Northrop, the rest of the industry, and we said we're gonna aggregate our very, very best models, and we're gonna build virtual prototypes of every aircraft, every tank, every boat, and that will be the driver to make design decisions. Within 24 hours, the team disbanded. And it didn't disband because the technology wasn't there. It disbanded because nobody wanted to share their design tools. Nobody wanted to share their data. That was their unique competitive advantage. So I really want to talk you through the business case of how you go into a market where the data's in a silo. It might be your silo. There might be other public domains for that information, but how can you structure a tool to do a large machine learning exercise for you that still keeps it proprietary to you and make sure that you're getting to market first, you're getting to the patent office first. So what do we do at Citrine? We are a Silicon Valley-based company. We're about 25 guys. We're about 3 years out of the gate. But we are making a move to Pittsburgh because what we do is we try to accelerate your time to discovery. And we try to cut your discovery time by a factor of 2. So what the mission really is for us is this is adding velocity to your R&D programs and making them more efficient. Today, when a large corporation sets out to discover a new material or solve a manufacturing process, it can be a 6-month process, it's more generally a 36-month process. We want to build large data tools that are custom developed for your enterprise that allows you to slice that time in half, get the savings, and get there faster. And we're relatively proud of this. This was 2 weeks ago in Santa Barbara, California. We were named onto the AI 100 for most innovative startups in the AI space. Why I'm particularly proud of this is we pop up on the lower right-hand side in the category of other. We don't share a lot of peers. We're taking on a science challenge, and we're doing it with AI tools. So we're blazing relatively virgin ground here. And what I believe, and I think we've heard this through the course of the day, big data is here. Big data can be a problem if not properly directed. And the next step in solving that is bringing on the machine learning tools and the artificial intelligence tools that are going to make it meaningful, going to make it actionable for you, the user, you, the corporation. So these are illustrative examples. Google, announcing that they're going through a 10-year transition. That should surprise nobody. Amazon, and this is a great quote from Jeff Bezos, that we're going to have AI thinking first. So using the computer to help you make intelligent decisions, not make the decision, but give you a tight bullseye of potential options that you can shop within. So that's Silicon Valley. We would expect to hear that coming out of the Bay Area. But here's the truth. There's hardly a single company today that isn't a data company on some level. They're either being proactive with their data or they're being passive with their data. But a lot of companies are waking up to the reality that they need to create differentiation using their data to drive actionable results. Jim's slide that indicated that 90% of our companies today are collecting data, 2% are taking action on it. We need to be much more effective on that front. We need to be collecting that data, and if 90% are collecting it, why aren't the majority taking action on it? They don't know how to organize it. They don't know how to structure it. They don't know how to find signal that's meaningful for their business. And that's the final point. You need to find that meaningful signal. You want to create sustainable competitive advantage with the insights that you find from that data. So if everybody's a data company, and it's not just Silicon Valley, aren't we seeing it? Shouldn't we be seeing it now in our more mainstream businesses? We are. And there's early movers. And of course, GE comes to the top of this. The quote from Jeff Imlet: industrial companies need to become digital companies. This will be a critical differentiator. It's fundamentally changing the way that we work. And if you look to the media today, artificial intelligence in the cloud starts to reshape everything. So within my particular domain in the material science world, I've got diverse sources of data. I have some that are verifiable. I have some that come from reputable sources. I have some that come from independent researchers and need to be qualified. There's a lot of silos. So what we set out to do is provide structure that and aggregate it in a way where it rewards all of the participants and gives them a clean business case. Whether you're an academic researcher or you're a company trying to discover new materials, where you can share your knowledge. So pulling into a single source, connecting the dots, allowing companies and academia to work together, and then closing gaps. If you look at any academic paper, you look at any industry paper, you're going to see roughly 5% or less of the actual physical results that they have run for their R&D campaign over the course of 2 to 3 years. They publish what's meaningful for their patent. They publish what's meaningful for their customers. The vast amount of that R&D data is lost. It ends up on the factory floor. We want to create processes where you can stream that data, we can capture it, because good physical testing data remains good data. even if it's not immediately applicable to the research that you're conducting. So what we're really doing is we're wedding the researcher to the machine. We're not replacing the researcher. We want to make the researcher smarter. We want to break down some biases. And we want to have them looking at their computer as a heads-up display to help them think differently about what they should be exploring for their R&D campaign. So I want to talk about chess. And this kind of blew my mind. It was 20 years ago that Deep Blue beat Garry Kasparov at a game of chess. That was the first time we saw a AI engine that was able to outperform a human at a highly complex process. And Kasparov's reaction to that was, well, the game of chess is now dead because everybody's home PC will beat them. This is not an interesting game anymore. So what he recommended, and what you see today with chess tournaments around the world, is what they call centaur chess. It's actually an amateur, a novice on chess rankings, which I actually think would easily beat me without their computer. They play against grandmasters. And to date, over the course of the last decade plus, a grandmaster has never beat an amateur working with a computer, because that machine is capable of using brute force to go through millions of calculations to identify non-obvious moves. A general rule of thumb in the game of chess is you don't lose your queen. And there's instances when it's a brilliant move to lose your queen, and the computer can point you in that direction. So the human still plays, but they make moves that they wouldn't have otherwise made without the power of those millions of computational options that are being generated for them in real time. So really, that's what we do. We are a game of centaur chess for the material researcher. And what we have built is we've built a live streaming platform. We have over 18 million data points that are streaming into our platform that are experimental, they're simulations, and they're linked, they're relational, they're meaningful for the researcher. And we use brute force. We're able to build very sophisticated machine learning engines to go and attack manufacturing and R&D problems that are science heavy. The R&D department, the researcher, he's still in charge. He still makes the selection. And he's going to make an intelligent selection. And he's going to make that selection based on the business case that he's pursuing, whether that's to be first to market, whether that's to get more efficiency in their process, or whether to bring an entirely novel design onto the market. So we try to keep our eyes on the prize when we work with our customers. We know our customers are trying to make shinier paints. They're trying to make stronger steels. They're trying to make a vehicle lighter so it would be more fuel efficient. Or they're trying to make it more recyclable, a greener supply. So what we do is we extract on volume documents out on the public domain. We can scrape patents. We can scrape academic articles. We can scrape your data, your testing data that you've had locked in a filing cabinet since 1972, and we can pull it out and find those data points and then put it into a structure where it's meaningful to you, and then we live stream. And I'll talk about that in a second. It results in the largest platform that we're aware of today in the world on materials data. And then we work with our customers to build engines. So I got a data challenge, and it's a little bit different than a lot of the data challenges that you've heard today, because there's a robust data pool and we need to target at something. I've got chaos in many instances, and I got to organize that chaos. And then I got to add some intelligence to it, to point it at a business problem and make sure that we are driving towards an actionable insight, an actionable result. It's embarrassing that 2% of the companies are taking action on this. It needs to be the vast majority, but you have to have the engines and the tools in place to do that. And so we cut across a number of markets. Yes, we start with new materials discovery, but the iPhone or the Galaxy that you have in your pocket, there's about 50 different materials that go into that. whether it's the polymers, the adhesives, the metals, and actually engineering that particular product is a huge material science problem. Because you put a small strip of adhesive around the top of the iPhone, and then suddenly your receiver doesn't work anymore. Or you've reduced your receiver by 5%. And trying to reprogram the chemical compound that is that adhesive could be the difference between you being ranked by Consumer Reports as having a significantly better connected device than your competition. So we look at product design. We look at it in great detail, and then all materials live over time. If you're in the metals industry, you take it from the mine, you're going to refine it, you're going to smelt it, you're going to roll it, you're going to heat it, you're going to pound it, you might print it. In every step along the process, that material makes fundamental changes. So we need to understand those processes that you put it through. We can screen millions of combinations, we can identify novel properties. We can look at optimization for design by identifying the right materials that you're going to put into a complex structure. And then we can plan for manufacturing. We work very closely with our customers to say these first two steps are great, but if you added 10% more scandium to that part, I can't afford it. And I don't have a sourcing option for that. So we can act as an early warning signal for the entire manufacturing process. Look, that's driving business results. It's driving business decisions. Whether that's accelerated time to patent, responding to a competitor, looking at a regulatory change where you have to remove certain toxic items from your product mix, or optimizing your purchasing processes. R&D has a particularly prickly point in any large organization. They like their patents. They like their patents a lot. And a lot of software companies that have entered this market and tried to provide services to the R&D community wants to do the Solomatic split of the baby. They look to have half of those patent rights. I want none of your patent. I want to help you build your engine. I want to get you to the patent office, and I want you to be differentiated. We've made that very explicit in the way that we've structured our platform. So the users, yes, the research community, but it goes down to the purchasing, it goes down to the business development, it goes down to the marketing folks. Once you have a single domain to share these innovations in real time, you can start to forward plan for that next product launch. So what is the platform? I'll go through this fairly quickly. Yes, we have the world's largest data platform. It streams 24/7 with new data. And on that simple platform, we offer machine learning tools that our customers can use for themselves. In many instances, you'll have a lot of data. It's structured in an Excel sheet. It's got the right fields. We've pre-programmed a lot of machines to convert that Excel into an ML tool at the push of a button. You don't need me to curate that for you. That's a simple machine learning process that we can do. How do we get our data? How do we live stream? We've formed partnerships with over 100 universities around the world, from Germany to Japan, across North America, where they use our platform for free. They publish their data, they work with their colleagues, and we provide services to support those academic organizations so they have the best of breed machine learning tools in real time. We do not share the results directly from those universities, but we mine that data for signal on behalf of our customers. Likewise, we do that with government laboratories today, as well as several industrial consortiums. At the end of the day, as I started this talk, said this is all about creating a differentiator for an individual customer. So I'm very cognizant that you're not going to want to have your data live streaming into a platform for somebody else to find signal. That doesn't happen. We deploy dedicated clouds where we structure your data with the right tooths in the gear so we can talk to the master platform. Then we build engines. And those are unique engines driven off your data that gives you differentiation. But now you have a master platform with data that you can go out and mine, that you can go out and get signal from. And you won't be alone. There's multiple users, but they're locked up. You don't share one to the other, but you can communicate with the platform. So the platform itself, I mentioned most of this. Simple machine learning, live streaming from the community, running out of time. So I will go quickly. So within the customer sets, we are building dedicated, secure domains for our customers. Those have engines that allow the customers to go forth and create new innovations. It is firewalled from their competitors, from their customers. But once it's structured, you have the ability to work with your vendors. You have the ability to work with your customers. Your data can transfer easily because we put it into a common data format. And I will move through these quickly. We do host this on the cloud. We secure it on the cloud. That's how we run the overall platform. But it's all about velocity. We want you to get to the patent office first. We want our customers to have competitive advantage. And we've been very deliberate about solving a data problem in a very specific market that is big science. And I'm very proud to say that I got through this without sharing a single chemical compound today. I usually come in with a phase array diagram, but I won't do that. I can't talk about all of our customers, but we have deployed around the world. These are a cross-section of some of the customers that do work with us and are comfortable sharing their logos. So with that, thank you very much.